My name's Erin. I'm a software engineer at Pulumi on the service team, and I've been working on our policy as code solution for a number of months now. Cameron, would you like to introduce yourself?
Yeah, and I'm Cameron Stokes. I'm a customer engineer here at Pulumi, so I help out on the customer side of things and support side as well.
So, one of Pulumi's main focuses is enabling engineers to deploy infrastructure quickly. And on the top GIF here, you see that we are creating a ton of resources, right? We're moving quickly, getting all of those resources provisioned. But that same stack below is actually halted to a stop because of the policies that we have in place. So we're going to first start with an overview of why we wanted to create a policy as code offering. And then we'll look at the approach that we took at Pulumi. And finally, Cameron will walk us through a demo so that we can see how you can use CrossGuard. In the past, there was a few select individuals or teams responsible for operations. This was a centralized team that had a lot of specialized knowledge on infrastructure. But now as we move to more distributed engineering teams, sort of this DevOps model, more and more people are responsible for infrastructure. And moreover, there's a lot of complexity with the number of cloud offerings, as well as the number of clouds out there. Pulumi makes it easy to go multi-cloud, but we wanted to also provide a way for users to do so safely. So we asked ourselves how we could help build in guardrails for organizations to go multi-cloud. And there's a lot of articles out there we see kind of pretty frequently about a misconfigured database or a misconfigured S3 bucket. So our answer to this was CrossGuard. Using policy as code, you can write expressive policies that enforce security practices, best practices, cost control, etc. And these policies get organized into policy packs. We leave it up to you on what you want to include within a policy pack. So you may choose to make one that is AWS based. You can make one that's cost based. It's really up to you how you want to organize the policy pack. And here we have an example policy pack with just some AWS rules. There are two policies, and each policy has a name, a description, an enforcement level, and a validate resource or validate stack, and we'll get more into that later. But basically, it has an enforcement level, which is either mandatory, meaning it will prevent the actual resource from getting created, or advisory. This is just some advice that I'm giving, but they can still go ahead and create the resource. And then there's that validator. So validate resource here is what's actually validating the resource and is what's checking that the resource is in compliance. Using general programming languages, we're able to write policies that are expressive for a variety of use cases. So let's go look at a bit of those different use cases that we see. So first, cost optimization. You can write policies that ensure that a particular stack is meeting some cost related guidance. So for example, you may want cost allocation tags on your resources, which is this first policy that we see here. You may also want to have lifecycle rules on logs to make sure those are getting cycled out appropriately. Your policies can ensure your data is properly protected. So here we have one policy that requires that storage be in US regions, and another one that requires that versioning is enabled on S3 buckets. Obviously, security is something that often goes with policy. So here we have one policy that prevents older versions of RDS or older versions of managed services. You want to make sure that you're always using up-to-date managed services to get newer security patches and things like that. And the second rule is making sure that your security group is not accessible from the public internet. So using policy in terms of security, you can make sure that your environments are always secure. And lastly, we see policy also being used for enforcing best practices. There may be best practices within that piece of technology. So for example, here we have a Kubernetes policy that doesn't allow the use of pods and instead encourages the use of deployments or replicate sets, something that has that built-in replication. Now, this is like a technology best practice, but there may be something that's like team specific. You may have a naming convention that you use, things like that, that can also be written into policy form and then enforced on all your resources. Okay, so kind of have an idea of what policy is, and let's have Cameron now walk us through a demo of policy as code in action.
Thanks. So to start, I'll spend a quick minute or two just describing this Pulumi application that I'm going to use as part of the demo. This is a TypeScript application, but the same principles, the same concepts apply in all of the different languages that we support. It's also an Amazon demo or example, but again, same concepts in terms of how the Pulumi application, as well as how the policies that we'll show here in a bit, also can apply across the different providers that we have as well. So at the very top of this TypeScript file, I'm just doing an import of our AWS X, and our Pulumi software libraries. These are node libraries because I'm writing in TypeScript, but again, these are available in all the languages that we support, and these are just standard language libraries to provide the capabilities of AWS and Pulumi as such. Beyond that, I'm importing a number of configuration values. Some of these are coming from the Pulumi config system itself. Others are coming from like an AWS query to find an Ubuntu AMI or an Amazon AMI and so on. And then we're going to use the Pulumi config system within this file directly to pull some values out. Define a few constants here at the top. So a set of tags that I'm going to apply across all of my different resources, a public and private network space to use as well. And then the next bit is where we actually get into defining our actual resources that we're going to deploy and manage using Pulumi. In this case, I'm going to create a VPC. This is using our AWS X crosswalk library that makes it really easy to create kind of best practice VPCs in just a few lines of code without having to redo that yourselves every time. Beyond that, we're going to create a security group. We're going to reference our VPC that we defined above as an input into our security group and just define an ingress rule on that security group itself. And then lastly, we're going to create a number of EC2 instances, and we're doing this based on this instance count configuration value that we're setting as a part of our Pulumi config system. And then you can see we're just doing a simple for loop to create an instance based on that instance count. That instance itself has an instance type that is set on it, in this case a T3 medium. We're going to associate a public IP address. We're going to use an Ubuntu AMI, use the subnet from our VPC, and so on and so on. So pretty straightforward Pulumi application here, pretty straightforward architecture, just a VPC, subnet, all of its related resources in that AWS X VPC, security group, and an instance. So kind of the normal flow of deploying an application or deploying infrastructure using Pulumi is to do a Pulumi up or a Pulumi update. The first thing this update is going to do is actually run a preview. So this preview is kind of the dry run phase of Pulumi execution, which is it's going to show you what Pulumi is going to do before it actually does anything. So this is your chance to review this preview, decide, yes, this looks good based on the code that I've written. This is the number of resources that I expect, and so on. So in this case, we see my VPC, the subnet and route tables and so on that go into creating that VPC. See my security group, and lastly, my instance count configuration value is currently set to 3. So I'm having 3 instances be created as a result. So all that looks good. So I'm going to go ahead and hit yes for Pulumi to go ahead and start creating and deploying these resources for me. And you'll see it should be pretty quick. Probably take about 30 seconds here for everything to kind of get up and running. Looks like we're kind of done with all the VPC and related resources, and now just waiting on those instances to start up. And again, this is without any policy in place. So I essentially have full access to all the resource types and attributes and properties and such that I want to set here. the very end, it prints out a link into the Pulumi console. So this is where we actually capture the same output data that we saw in the command line. We're going to actually expand this and see the full diff view of each of these resources as well to kind of see all the specific details that went into creating those resources. So let's say we actually want to put policy in place and put some kind of guardrails on this to kind of limit what we're doing and limit some of those bad practices that Erin mentioned earlier. So to do that, we create a policy pack, as she described. So in this case, our policy pack is named EC2. So all of these are going to be EC2 related policies or AWS related policies. But as Erin described, these can be kind of any grouping that you want to do of your policies. So that could be cost reporting, that could be security, that could be best practices, and so on. This first policy that we have is going to do a resource validation, or essentially a resource check. So it's going to check every EC2 instance in our stack, and it's going to check that the associate public IP address value is set to true. And if it is, it's going to report a violation that associate public IP address should be set to false. So essentially, we're just checking that, or rather, we're discouraging the use of public IP addresses directly on our EC2 instances. And we're doing that with the enforcement level set to advisory. So this means that it will be allowed. I'll be allowed to continue with any deployments that have these violations, but I will get a warning when I do that is discouraged. Our next policy is to check for required tags, and specifically it's going to check for a name, a cost center tag, and a stack tag. This one is set to mandatory, meaning that any violations that are found will actually block or prohibit my update from continuing if those violations exist. So again, we're specifying the type of type of resource that we want to check. We're going to check for a cost center tag, and specifically we're going to check that this cost center tag matches the name of our project. So not just that it exists, but we're going to check the value of it as well. Same with our stack tag. We're going to check that not only does that stack tag exist, but it's set to the name of our stack. So in this case, it might be dev or demo or production. And then lastly, we're going to check that a name tag has been set. In this case, we're not picky about the value of the name tag. We just want a name tag to exist there. Moving along, our next policy here is going to check all of our AWS EC2 security group resources, and it's going to check that for each ingress rule on that security group and each CIDR block in that ingress rule is not set to the public internet. So again, just enforcing that we're not opening up ports to the public internet in this case. Again, this one's set to advisory, so just get a warning if we have any violations here. So a few more policies I'll go through, and then I'll actually show this in execution. So my next policy here is going to check for allowed or even prohibited services. So in this case, we're specifying that IoT and Redshift services are prohibited. So I am not an IoT developer, neither am I a data engineer. I don't need to be deploying either IoT or Redshift resources. We just go ahead and prohibit those entirely. That means anything under the IoT and Redshift umbrella of services, or umbrella of resources rather, will be blocked from being deployed. Our next policy is a bit more of a complex one. So this is actually the stack validation that Erin described. So rather than checking an individual resource, we're going to be able to do kind of an aggregate check across multiple resources in our stack. So in this case, I'm just going to get essentially a reference to all of the resources in my stack. I'm just going to filter it based on AWS EC2 instance, that same resource type that we've been using. Just compare the length of that list of resources that is found against a maximum instance count variable, and if it exceeds that, report a violation. The distinction here is that we're making this maximum instance count value configurable. We're setting it to a default of 2, so we're actually limiting the number of instances to be a quite small number. But when we publish this to the Pulumi console and actually go into configure it, we can apply a different configured value here to different stacks. So meaning if I'm in dev, we might want to limit the size of those or the count of the instances in a dev stack to a small number. But if I'm deploying to production, I might need a much larger number in order to to service our production workload. So when I again publish this to the Pulumi console, I can set this maximum instance count to 100 or even 1,000 or something reasonable for our production workload. But for dev and less critical stacks, I want to limit the size of that and limit costs essentially. And then lastly, this is again kind of a more of a complex check. We're going to check that the AMI that I specified is actually owned by the appropriate account. So in this case, we want to allow self, so meaning any AMIs that my account owns or are within my account, or any AMIs that are owned by Ubuntu. We trust that Ubuntu is publishing hardened, trusted AMIs, so we're going to allow AMIs from them as well. And this one is, again, a bit more complex because we're actually going to use the AWS API itself to query for details about the AMI that has been specified, and then check the owner ID value of it compared to that list that we specified, and then report a violation based on that. So this is one that's a bit more dynamic, and then we're also querying for additional data as a part of this violation, or part of this policy, rather.
So now that we know how we can use policy, let's take a look at how we went about implementing it and some of the features. So the first thing to policy is authoring policy packs. We currently support writing policy packs in TypeScript, JavaScript, and Python. And our multi-language approach actually allows you to use a policy pack of another. So you may have a stack written in Go, and you can enforce a policy pack that's Python-based. There are two types of validations. There's resource validations, and those are sort of what we looked at earlier. And those validate a particular resource type. And they're run before the resource gets created or modified. There's also stack validations, and those allow you to look at the stack as a whole and validate against all of the resources. These get run after all the resources have been registered with the Pulumi engine. And so if you want a stack validation to actually halt the deployment, you do need to run it in a preview, and we'll see that later on in our demo, that stack validations still can halt in a preview. Okay. We've added a policy pack flag, and this allows you to run policy packs locally against a stack. This is great for development of policy packs, as well as it's part of our open source offering. So you can use this without actually using the Pulumi service. And it's also a great way to run some tests. So there is actually a blog post, I don't know if it's out yet or coming out, but on using policy packs for testing. So using the console, you can also enforce these policy packs on your organization. So there's a concept of policy groups. Policy groups are basically just a grouping of stacks. And then you can enforce a policy pack on that policy group. This can be used for having one set of policy packs and policies for non-prod and a different set for production. Using the Pulumi service allows you to automatically enforce these policies on your stacks, and therefore can catch problems before they get into production. So it actually incorporates the policy pack as part of your CI. And lastly, we've made policy packs configurable. So we wanted people to be able to reuse policy packs from one environment to the next, which sort of talked about earlier, having maybe a policy group for non-prod and a different one from prod, and likely you will have different sort of requirements or restrictions between different environments. And so in this example policy pack, we have an allowed regions array that is configurable. We've set the default to be US West 2, but using the console, we're actually able to go and add regions to that allowed list instead of having to go in and edit the policy pack and republish it to the service. And by default, we also have the enforcement levels configurable, so those can easily be adjusted too.
So let's see this in action. So I've already completed my Pulumi update. All of these resources have already been deployed. So if I actually want to run this with policy in place, I use that policy pack flag that Erin mentioned. This is just going to run this policy pack code that I've just referenced in my local directory. Show me any violations that currently exist. So in the output here, we have a number of violations. Each of these violations is based on one of these report violations calls, and it's going to specify the actual resource type and specific resource that had the violation. So if I scroll up to the top here, we see the very first one that we hit is that discouraged EC2 public IP address policy, and it's going to be for actually each of my instances that I've defined. So this next two policy violations are the same thing, but just for the other instances of that instance. Next violation we have is that my security group is in fact opening up a CIDR block or opening up an ingress rule to the public internet using that 0000 CIDR block. I do have too many instances defined in this stack. So based on that instance count config value, I'm specifying, or rather I'm deploying more instances than I should based on a default of 2. And then I'm certainly missing some tags here as well. So my cost center tag does not match my project name. My stack does not match my stack name, and so on and so on. So I've got a number of violations I need to fix up here. So I'll show fixing a few of these, and then I'll go into actually publishing this policy pack to the console and seeing the result of that as well. So just to do some quick and easy ones here, I'm missing that base tags value within my tag, so that's going to add back my cost center and stack tags to my instances. I'm going to go ahead and switch over the network, that CIDR block that I'm specifying as well as a part of my ingress rule. So I've not actually fixed all of these. I'm just going to show what this looks like after fixing a few, and then we'll go through that publishing workflow. So again, we're going to see the same preview that we saw before. We should just see a lesser number of violations at this point. So I'm still exceeding the number of instances that are allowed. I have not yet actually addressed the associate public IP address property, but you can see I've cleared up the tags, and my CIDR block violation is gone as well. If I scroll further up, we can actually see in the preview the actual change that would happen if I were able to continue with this update, but I need to clean up the rest of those violations first. So what I'll show now is actually publishing this policy pack to the console and seeing how the console can provide that organization-wide enforcement across all of the stacks in my organization, so that I have kind of a strong guarantee that my stacks are following policy and following those best practices that we've specified. So I've just changed directories into my policy as code directory where my policy pack code lives. I'm going to use the Pulumi command line just to publish this policy pack into my demo organization. So really all this is doing is just kind of zipping up this code, pushing it up into the console so that I can configure it and enable it within the console. So provided a link for me here at the end of that publish. So I can click in. I can actually see some kind of high-level details about the policies that are in place in this policy pack. I can see the names, the descriptions, their default enforcement levels. I can actually override this enforcement level when I configure it, when I apply this. So if I click over to policies, again, when I'm within my demo organization, so this is the point at which I can enable that policy pack that I just published, and then have that organization-wide enforcement through the Pulumi console. So we have a default policy group. Again, a policy group, as Erin described earlier, is a way to group and enable your policy packs across the stacks within your organization. This default policy group just lets me turn on, or rather enable a policy pack across every stack in my org. So I'm going to hit add, going to select the policy pack that I just published, and we select the latest version as well. So we actually allow you to publish new versions of your policy packs without yet enabling them or putting them in place. So this lets you have kind of a controlled and staged rollout of updated policies so that you're not surprising your developers and interrupting their workflow. So once I've selected that latest version, now I'm given the option to configure it. So we can see in my allow AMI owners policy, we have the default values that I specified in the code itself, so of self and then the Ubuntu account. We have all the enforcement levels that I can configure. And then lastly, we have our maximum instance count policy, which is currently set to 2. So again, I'm going to leave that as default. I'm going to hit submit. Go ahead and enable this with those default values. And below, we can see all the stacks that this is going to apply to. So I've been working out of this demo AWS TS Web Server demo stack, but this also applies to every stack in my organization. So now that I've enabled it at the organization within the Pulumi console, when I come back to my development environment and go to do a Pulumi up, the Pulumi client is actually going to handshake with the console and effectively say, hey, which policy packs do I need to run alongside this preview? Download them and run them just as it was doing before, but without having to specify that policy pack flag. So again, as a developer, I don't have to remember to run that every time. The console is ensuring that it's getting run every time, regardless of providing that flag or not. So we see the same violations that we saw before. If I go into the console here, I can actually see that now that policy is enabled, I can see all of the stacks that my policies are being applied to. So at a quick glance, I can see that I have policy enabled across every stack in my org. And I can click into the demo stack specifically and see the history of it here. So through all the updates I've been doing so far, I don't have policy in place. I've done that preview, but I've not yet actually completed it up. So let me resolve this last violation, and then we'll continue with that update and see that in the console as well. So my instance count value is again coming from that instance count configuration value. So I just need to do a Pulumi config set instance count and set it to 2, which is that maximum number of instances that's being set. Now when I run a Pulumi up, I should see those same advisory messages that we saw before, but now that I have no mandatory violations, I'm actually allowed to continue with this update at this point. So this looks good based on my updates. We can see by changing that instance count config value from 3 to 2, we're actually deleting that third instance in this case, which is what I expect. Go ahead and hit yes, and now Pulumi is going to go and update my security group with its ingress rules, update tags on my remaining instances, and delete that third instance at the same time. If I go back into the console, I can see that particular update in flight right now. I can see that it's protected by policy, and here in the next 10 seconds or so, that instance should be deleted, and we should be done. There we go. So in this case, we can see kind of the hint as to what happened as a part of this update, but we can also see that it's now protected by policy. So just to recap what we've seen, we saw how we can have policies that enforce cost reporting, so make sure that there's a cost center and a project tag on our resources, enforcing security best practices, so not assigning public IP address, not opening up security group rules to the public internet, and then probably most importantly, publishing those policy packs or policies to the Pulumi console and getting that organization-wide enforcement of policy across all of the stacks in my organization. So I know that any of my developers that are pushing or promoting updates through any of the stacks in my org have these policies in place to protect them and have those guardrails in place so they're not doing anything against those best practices and against those policies.
So now that Cameron has showed us what policy has to offer, you can go ahead and try it out for yourself. There are a ton of resources to get you started. For starters, we have a getting started tutorial on the pulumi.com site. We also have examples in the examples repo under the policy packs subdirectory. There's example packs there for AWS, Kubernetes, Azure, as well as Google Cloud. We have a sort of token policy pack, which is our AWS Guard. It sort of shows you how to structure some larger policy packs. And then lastly, we have our Pulumi policy repo, whereas a lot of the magic, or not magic, but code behind the CrossGuard is in here. And it's also where you can open up issues for new features you'd like to see or any issues that you encounter.